Hello everyone, and welcome to the Analyst Day for Redwire. My name is Bill Reed. I am the Chief Financial Officer for Redwire, and we are very happy that you chose to spend some time with us this morning. We're exceedingly happy to have the opportunity to introduce you to Redwire. As you may be aware, we are going through the process of becoming a public company via merger with Genesis Park Acquisition Corporation. We filed our S-4 with the SEC on Tuesday, July the 6th, and are targeting the completion of our business combination in the third quarter of this year. Moving to our presentation, on pages 2 through 4, we have included the usual and customary disclaimers. I am not going to review all of these disclaimers in detail, but I do request that you take some time to review these pages at your convenience. I would like to point out the disclosures on forward-looking statements on page 2. This document includes forward-looking statements within the meaning of the safe harbor provisions of the United States Private Securities Litigation Reform Act of 1995. Forward-looking statements may be identified by the use of words such as forecast, intend, seek, target, anticipate, believe, expect, estimate, plan, outlook, and project, and other similar expressions that predict or indicate future events or trends that are not statements of historical matters. Such forward-looking statements with respect to revenues, earnings, performance, strategies, prospects, and other aspects of the business of Genesis Park Acquisition Corp., Redwire, or the combined company after completion of the business combination are based on current expectations that are subject to risk and uncertainties. A number of factors could cause actual results or outcomes to differ materially from those indicated by such forward-looking statements. Moving on to page 5 of the presentation. I will give you an overview of the agenda for today's presentation. To begin with, our Chairman and Chief Executive Officer, Pete Canito, will provide you with an executive overview. Next, our Chief Operating Officer, Mr. Andrew Rush, will dive deeper into our products and capabilities. Mike Snyder, our Chief Technology Officer, will excite you with our innovative and disruptive technologies. Al Tadros, our Chief Growth Officer, is going to discuss our markets and customers. Faith Horowitz, our Chief Administrative Officer, will discuss our critical human capital and the communities that we are a part of. And I will finish up with a discussion of the financial performance and projections. With that, I'll turn the presentation over to our Chairman and Chief Executive Officer, Mr. Pete Canito.
Thanks, Bill. All right, well, I am extremely proud to introduce some of the Redwire team that is here with us today. As Bill said, my name's Peter Canito. I'm the Chairman and Chief Executive Officer, and we have assembled a world-class team of executives here at Redwire that have a really diverse group of experience, everything from startups to large businesses. I myself have 25 plus years of experience working in the aerospace and defense industry. Redwire is the third high technology, high growth platform that I've had the privilege to lead, and I've been working very closely with our partners at AE as an operating partner, advising them on aerospace and defense mergers and acquisition. With me today also is Andrew Rush, our President and Chief Operating Officer. Andrew was the CEO of Maiden Space, one of our critical acquisitions during the formation of Redwire. He is also a former attorney focused on intellectual property, which is critical to Redwire because intellectual property is one of the foundations of our strategy. He also chairs the NASA Advisory Council Regulatory and Policy Committee, which is extremely important to us because it underscores his trust to the customer. Andrew is very well known throughout the space industry, and we're very happy to have him as part of our team. You just heard from Bill Reed, our Chief Financial Officer. Bill has over 30 years of experience in a variety of strategic and operational finance roles. He is the former CFO of a number of both private equity-backed as well as public companies, and has extensive M&A background ranging across the full gamut from financial integration all the way through back office experience. We also have with us today Mike Snyder, our Chief Technology Officer. Mike is the father of 3D printing in space. He was one of the founders of Made in Space and is very well known throughout the industry as a technical leader, particularly in the area of advanced manufacturing on orbit. We will also, and you will hear from today, Al Tadros, our Chief Growth Officer. Al comes to us with over 30 years of experience as a space innovator. He came to us from Maxar, which, as I pointed out in the beginning, we have a combination of both a small business startup and large business experience. And Al just brings us a tremendous amount of that large business experience as we continue to grow here. And I think it's always a good sign when you have a high-tech, high-growth company whose head of business development also has a undergraduate and master's degree from an institution like MIT. We also have with us today Faith Horowitz, our Chief Administrative Officer. Faith is a serial entrepreneur. She has over 30 years of experience in operations management and has started a number of different companies successfully and grown them successfully over her career. Lastly, also with us today, I'm proud to say, is Jonathan Bailiff, the President, CFO, and Director of Genesis Park, who has just been an outstanding partner to Redwire, to us, as we go through our SPAC process. John has a tremendous amount of experience, over 30 years, in aviation and infrastructure. He's the former CFO of a public company and CEO of a public company, and it's just been extremely empowering to have Jonathan with us with his public company experience and background helping us through this process. The one thing I really want to point out here about this team, because I believe that it is very unique and a major competitive advantage for Redwire, is the amount of experience we have in mergers and acquisitions. For a high-growth company that's in the phase of growth that Redwire is currently in, that's very unusual to have a team with such a depth of M&A experience. And in addition to our fantastic organic growth story, that M&A experience helps us to be able to significantly accelerate growth as we execute our strategy. Moving to slide 7. So here's a quick snapshot of our investment highlights. Redwire is truly unique as one of the few revenue and cash flow positive pure-play space companies with scale. We are unique among our SPAC peer group in that we are generating significant revenue and cash flow today on deployed space capability, but also possess equal or greater breakout growth for the future. This is due to our highly differentiated heritage plus innovation strategy. We combine the proven flight heritage of a traditional space company with the disrupted innovation, such as 3D printing in space, of a new space startup. This positioning is directly attributable to our purpose-built approach to growing Redwire today. Moving to slide 8. Before I jump into the presentation, I want to take a moment to highlight this image, and in fact, all of the images you will see throughout this presentation. It is unique amongst our presentation here that we have not put into the presentation stock images of space capability. These are actual images that you will see throughout of real Redwire capability deployed today. This photo in particular is of NASA astronaut Shane Kimbrough installing the second Redwire Rollout Solar Array, or ROSA, product on the International Space Station. This spacewalk was conducted recently on June 25th of this year, and I can't think of a better image to depict just how critical our products are to our customers, the nation, and humanity's future in space. We have a bold vision, but this is not science fiction. This is happening now. As such, moving to the next slide, I'm honored to share with you this video describing our ROSA technology.
This laboratory, orbiting above, has redefined what it means to live and work in space. At Redwire, we build the innovations that enable success for our partners. In 2017, our team successfully showcased a first-of-its-kind technology called the Rollout Solar Array Structure. a strong, compact, and efficient solution for deploying arrays on a flexible blanket without motors or complex mechanisms. Now, Redwire's patented ROSA technology will deploy 6 Boeing Spectrolab solar arrays on the International Space Station. Collectively, these will provide an additional 120 kilowatts of power, a 20 to 30% boost that will power bold new science and technology demonstrations, like Redwire's many in-space manufacturing payloads for years to come. With the station prepped and ready, the first 2 iROSA arrays will launch aboard SpaceX's 22nd commercial resupply mission and be installed by NASA astronauts. The remaining 4 iROSA arrays will be deployed over 2 additional missions in 2022. Because ROSA provides unparalleled, highly modular power generation in an affordable, compact solution, designs are in development for use on NASA's Artemis Gateway, with commercial and civil missions on the lunar surface, and for use in deep space on NASA's DART mission. ROSA is just one of Redwire's capabilities that will accelerate humanity's expansion into space and deliver on our promise to be the mission partner of choice for those who lead the way. At Redwire, we build above.
Truly extraordinary. We are extremely proud of the iROSA team and our partnership with NASA and Boeing on this effort. But iROSA is only one of many examples of game-changing technologies we have that are shaping the future of space. And we will cover many more today, because here at Redwire, we are on a mission to accelerate humanity's expansion into space by delivering reliable, economical, and sustainable infrastructure for future generations. This is important because with the reduction in launch costs, there is going to be an unprecedented expansion of space infrastructure in the coming decade. Moving to slide 11. We are at the beginning of a second golden age of space. But unlike the previous space era, the new space gold rush will not just be about exploration and national prestige, but rather economic expansion. Space is the next major economic frontier. And there are a number of factors driving growth in the space industry. For example, the hyper-competitive launch market is driving down the cost of deploying space capabilities. This is making new business models such as commercial Earth observation, proliferated small satellites, commercial space habitats, and commercial space habitats that were historically not economically feasible commercial offerings in the near term, which is exciting for us because Redwire is positioned to be a leader in providing the infrastructure for this economic expansion. Moving to slide 12. Let's talk about how immense this opportunity really is. We're not just talking about rockets, although we do offer key components to the launch community. We aren't just talking about satellites either, although we also offer many critical solutions that will grow tremendously, along with the extraordinary growth in the satellite industry. We are talking about the industrialization and commercialization of space. We are talking about critical infrastructure that includes Earth's orbits, such as commercial habitats, beyond Earth's orbits, such as cislunar and lunar structures, Mars, and throughout the entire solar system, to include the sun, which we'll highlight a key technology in that area later in the brief, and even out into deep space. So as you can see on this slide depicts our vision for the future of space commercialization. And each one of the Redwire logos associated with these technologies represent either a technology that we are currently performing on today, or one that we are in the process of developing capability to play a critical role in the future. Moving to slide 13. So how does that relate directly and tangibly to Redwire and our diverse set of infrastructure solutions? In other words, what is Redwire's role in this immense opportunity? Space infrastructure is the foundation of space commerce, similar to how terrestrial infrastructure is the foundation of terrestrial commerce. And Redwire provides the key building blocks for the future of space commerce. In the new space gold rush, we are providing the picks and shovels. So looking at this slide, you can see on the left, you have the building blocks of terrestrial commerce. These are those key infrastructure capabilities that we rely on every day in order to do our jobs, such as power, computing power, reliable communications, capital equipment, manufacturing and otherwise, and the engineering and design tools in order for us to execute our product development. Analogously, on the right side, you have the building blocks of space commerce. Self-building structures, power, navigation, control, and awareness with advanced compute powers in these advanced sensors, in-space habitats, capital equipment such as 3D printing for on-orbit manufacturing, and the digital engineering design tools to make sure that you can build and deploy this infrastructure cost-effectively. This is how Redwire enables the future of space commerce. Think about it. The most advanced piece of space infrastructure currently in space is the International Space Station, and Redwire is providing the power. Moving to slide 14. So what makes Redwire so well positioned as a leader in space infrastructure? In short, what makes us different? It's our highly differentiated heritage plus innovation strategy. We have assembled a purpose-built company that includes the best of both traditional and new space companies. We have the proven past performance and deep relationships that provide our customers the confidence we will deliver, combined with those breakthrough innovations to fuel tremendous future growth. And as you can see from the bullets on this slide, our heritage part of our Heritage Plus innovation strategy includes enabling every U.S. mission to Mars, in providing critical sensors for deep space probes that have gone to Pluto and beyond, and even providing critical capability for the GPS constellation close here to Earth. We're also delivering today. You saw our iROSA solar arrays that are installed on the ISS. We currently have numerous 3D printing capabilities already installed on the ISS, and we've been there since 2014. We're currently building machine vision, advanced machine vision and camera systems for the Firefly lunar lander, which we'll talk more about that later on in the presentation. And we also supplied key capability to include navigation sensors for the Perseverance Mars landing and thermal software to help with the analysis for the Ingenuity helicopter. We have delivered in the past, we are delivering in the present, and therefore we will be trusted to deliver in the future. Next slide. So how does all this translate into financial performance and a great investment? After all, everyone's on this call not because they want to be future space tourists, although I'm confident many of you secretly do, but to hear about Redwire as an investment. Well, it's our highly differentiated Heritage Plus innovation that provides us a strong foundation of current revenue, cash flow, and backlog that enable sustainable growth for the long term. I like to describe Redwire as having a blue chip foundation with venture optionality. Our strong current performance combined with significant backlog and contract momentum, fueled by a robust IP portfolio and many one-of-a-kind game-changing technologies, accelerated by a rapidly expanding market with many tailwinds, gives us the confidence that we will deliver on our 5-year forecast. Moving to slide 16. So how did we create this differentiated Heritage Plus innovation strategy? We built it from the bottom up. Redwire is uniquely positioned as a first mover industry consolidator. Remember when I was introducing the team how I highlighted how our M&A experience was a competitive advantage. Space is a highly fragmented market, and Redwire has been the buyer of choice, combining niche technology companies that provide tremendous flight heritage with new space startups with disruptive technologies. You can see the list of our 7 acquisitions on this slide. And I like to use the example of AdCol Space and Maiden Space to really bracket our Heritage Plus innovation strategy. AdCol has been operating in space for over 50 years with sensors on over 150 plus missions throughout the solar system. Maiden Space is a new space company that is changing the economics of space using 3D manufacturing on orbit. By combining these companies, we get the best of AdCol's flight heritage with Maiden Space's disruptive technology. This is heritage plus innovation. This is blue chip foundation plus venture optionality. And the best thing is our successful track record of M&A has created a virtuous cycle of new acquisition opportunities. One of the things I'm most proud of about what we've accomplished here at Redwire is how quickly the companies have come together to form one Redwire. We are not a holding company. We go to market as a single integrated Redwire. And I'm proud to say that all of the founders of the companies that we have acquired who had meaningful roles in their day-to-day execution during of their legacy companies have taken on, much like Andrew and Michael, who you're going to hear from today, meaningful roles in the go-forward Redwire. This is part of our agility. This is part of why we're able to move so fast. Moving to slide 17. So as a result of our unique positioning, Redwire has emerged as a key partner across the high-growth space sector. At Redwire, we believe space is a team sport. Recall how I mentioned that the reduction in launch cost has enabled new business models. These new space capabilities require next-generation space infrastructure, and Redwire has teamed with the premier names in these new business models, these new space solutions such as Firefly, Momentus, Sierra Space, Maxar, and Viasat. You're going to see technologies throughout this entire presentation that highlight some of our efforts working with these extraordinary companies. And in addition to teaming with all these new space companies, we are of course teamed with the traditional space prime contractors, such as Boeing, as you saw on our IROSA technology, Lockheed Martin, Northrop Grumman, and beyond. Whether it's a civil national security or commercial opportunity in space, Redwire has a critical role to play. That's why we like to say, when space wins, Redwire wins. Moving to slide 18. Now, hopefully we agree that I've laid out a bold vision for Redwire. It's time to back that up. These next few slides in the remaining portion of the presentation will provide just a few examples of how Redwire is providing the critical infrastructure for the future of space. Starting with this slide on Perseverance. As many of you, much like myself, watched excitedly, we are particularly proud that we had some sensor capabilities on the Perseverance and how that, in partnership with NASA and the JPL and the other extraordinary members of the Perseverance team, our capability has performed. Next slide. And I'm going to go through these very quickly because you're going to hear a lot of detail, technical detail from Andrew and Michael as we move forward here. But we talked about our IROSA capability. This is just an extraordinary capability. These are the largest rollout solar arrays in space. When you talk about, and you go back to that slide that I show about the commercialization of space, power is so critical. And be able to bring that power in a form factor that can be deployed, launched, and then deployed reliably and quickly is so important to the future of the cislunar, lunar, and ultimately Mars infrastructure. We currently have 2 IROSA capabilities now installed on station at the ISS, and 4 more will be delivered and installed in 2023. Next slide. As I mentioned, we're working with those new space companies that are our partners as we move forward in developing the next generation space infrastructure. And I want to highlight here the Firefly Lunar Lander. Redwire is providing the core avionics for the Firefly Lunar Lander program, and this is a critical part of the Artemis program and the future of that space commercialization vision that I outlined earlier in the brief. Next slide. I mentioned we work throughout the entire solar system to include the sun. This is a example of one of our solar-based capabilities. We're very pleased to be on the Solar Cruiser team supporting our customer at NASA, for which we are providing an 8,000 square foot solar sail for this critical NASA mission studying the sun. Yes, that's 8,000 square feet. I think that's approximately, as the head of our group that runs this mission likes to say, about the size of a football pitch, although he's from the UK, so he means soccer. I'll translate for you out there. So so next slide, please. And we're carrying that momentum forward. This is a slide of the next 6 scheduled launches for this year. In the next 6 months, we will have an additional 6 launches that we're participating in, possibly more. I'm not going to go through each one, but the fact of the matter is, if there's a launch going up, there's a good chance there will be a Redwire capability on it. Now I'm going to turn it over to our President and Chief Operating Officer, Andrew Rush, who is going to convince you that we can deliver on all these great promises that I just made. Andrew, over to you.
Great. Thanks, Pete. It is just such a pleasure to be here today talking about the really amazing work that our team is doing that's feeding forward and making that vision that Pete was just talking about a reality. You know, this vision of accelerating humanity's expansion into space, of commercialization of space, and really enabling the second golden age of space. But before I get into that, I want to talk about this picture right here that we have on the screen. As Pete mentioned, a lot of the interstitial images that we have are images of real deployed hardware that we at Redwire have built and have turned over to customers and operate in space. This right here is a payload that's on the International Space Station called the Ceramic Manufacturing Module. This is one of several payloads demonstrating space-enabled manufacturing, which is one of the key pillars of low Earth orbit commercialization, of actually using space in new and interesting ways. In particular, this ceramic manufacturing module is demonstrating the proof of potential that when you take gravity out of the manufacturing equation for certain ceramic parts, you can actually make stronger, more reliable parts for really important and expensive and high-value applications, such as high-value rotating machinery and power turbines and the like. And we're using the platform of the International Space Station, like many other platforms, to include small satellite buses, large satellite buses, and the like, to demonstrate and operationalize these technologies that are driving humanity's expansion into space. So as I mentioned a little bit earlier, we deeply believe that this is the second golden age of space. You know, we have seen what the dramatic reduction in launch costs driven by economically reusable rockets has done to the $5 billion launch industry. And we've seen now the expansion of opportunity that reduction in launch costs represents in the proliferation of small satellites in low Earth orbit to provide telecommunications and other capabilities such as remote sensing in low Earth orbit and beyond. Our trusted and friends at NASA are driving forward with the Artemis program, returning humans to the moon, putting the first woman and the next man on the face of the moon, and then doing that in a sustainable way. You know, with folks like China, you know, also expressing ambition there, motivating almost a second space race to return and sustainably explore and operate on the moon's surface. And of course, with this expansion of both commercial and civil national activities in space, we have more things to protect, and we now recognize space as a contested domain, one that our colleagues in the national security sector strive to monitor and protect as necessary. All of these are driving this expansion in space, and we at Redwire serve two critical roles here, both as a trusted mission partner, enabling folks to be successful as we expand into space, as we flow through this second golden age, as well as with things like our ceramic manufacturing module, opening new markets and using space in new and interesting ways. So these tailwinds are driving massive expansion in the space sector. And with these trusted technologies and disruptive innovations, we at Redwire are facilitating that expansion and expanding market share relative to our competitors and compatriots in this sector. If we go to the next slide, slide 24. So this slide, I really like this slide because this is really kind of the building blocks of that vision that Pete was laying out for us a little bit earlier. What you see here on the left are our 5 strategic focus areas, and then on the right, how they feed forward, how they feed into that future space economy, the commercialization of space. So I'm going to walk us through these and give some detail on each, and then we'll go in the next couple of slides. We'll go into some case studies before turning it over to Mike Snyder, our Chief Technology Officer, to do more of a deep dive here. So our first strategic focus area here is that of space commercialization. So, which I kind of previewed a little bit earlier when talking about the ceramic manufacturing module. Space commercialization here at Redwire means 2 things to us. First, it means leveraging space, using space in new and interesting ways, like space-enabled manufacturing, via manufacturing things like ceramics, Z-bland optical fiber, and other objects that now, because we have both the launch infrastructure and the orbiting infrastructure, we're able to consistently and reliably send materials to space, do manufacturing or processing, and find those materials and those processes that when we bring those things back down to Earth, they have enormous economic upside. The other area that we're really proud of in space commercialization is that of applying commercial approaches to human spaceflight exploration and operations. We're proud to support our friends at NASA as well as private citizens and universities in their approaches and exploration and scientific endeavors on the International Space Station and beyond by taking a more commercial approach to enabling human exploration and operations on orbit, which is really critical because although we as a society have great ambitions in the exploration of space, we also have a checkbook, and we need to do that in an economical and reliable way. All of this is really important, feeding forward into this grand future of space that we envision, where we have commercial space stations in low Earth orbit. We have NASA astronauts and others exploring and living and working sustainably on the lunar surface. And one day, factories manufacturing materials in space that we use both in space and here on Earth, ultimately getting to thousands of people living and working in space. So this space commercialization thrust area of ours, we view as a critical pillar in supporting and delivering that vision and that part of the second golden age of space. Next, we have our digitally engineered spacecraft thrust area. So the way that we have traditionally in the space sector done satellite design, build, and manufacture comes in 2 flavors. It comes in either a very bespoke flavor that's very expensive, takes a long time, but you get exactly what you need, or it comes in more of a mass production, low or no customization kind of approach. You get the product faster, but it's kind of like the Model T approach, right? Henry Ford said, you can have it in any color that you want as long as it's black. That's really what we've seen in space with spacecraft currently, this kind of mass production, no customization approach. We at Redwire are applying digital engineering techniques to satellite design to quickly provide a tailored solution for our customers, whether it be for an entire single satellite, for a constellation, or for subsystems thereof, so that we can deliver low non-recurring engineering cost, quickly tailored solutions for our customers. Today, we're applying those techniques, and as well as the application of more commercial off-the-shelf parts and modern compute capability for a wide variety of customers that you see here on the screen. Looking forward to, as our space economy goes from 6,000 satellites on orbit to 50,000 satellites or more on orbit, these kind of approaches are going to be critical in lowering the cost and lowering the lead time of spacecraft development. So as our customers need to more rapidly respond to commercial opportunity or rapidly respond to emerging or potential threats, this is a critical piece to that puzzle. Our third strategic area is that of on-orbit servicing, assembly, and manufacturing of satellites. This is 3D printing and robotic assembly of satellites on orbit, which sounds really cool, and it is. But why? But why do we care? The reason we care is every single satellite that we've ever sent to space goes up on a rocket. And rockets are awesome. They're the reason that every 4-year-old loves space. But they're loud. They shake your satellite like it's a paint can shaker, and they subject it to enormous G-forces, all of which we as space sector professionals have to design around and design to survive. So what we're doing right now is we're actually designing satellites, not really optimizing them for the space environment, but really just to survive the rocket launch. But this is where in space 3D printing and robotic assembly come in. By building, by manufacturing and assembling satellites from piece parts and raw materials that survive launch quite easily, and sending those up to space with a kind of hardened, manufacturing plant, we can actually build the satellite in a way that's optimized for the space environment rather than just to survive launch, which means that we can deliver significantly more capability to our customer than the current state of the art for spacecraft design, manufacture, and maintaining. Further, this unlocks the capabilities of servicing of satellites. Because right now, the way that we do satellites is a lot like we used to do rockets, right? They're expendable. Once they run out of fuel or new technology comes along, we discard them, and then we put a new satellite out. Much like we've seen economically reusable launch vehicles change the game for the $5 billion launch industry, this technology, this on-orbit servicing, assembly, and manufacturing technology is going to change the game in the $20 billion satellite manufacturing sector. That's going to lead, as you can see in this slide, that will lead to us being able to deploy large structures that are much more capable than what we have today, and also make those self-sustaining and self-servicing, treating assets on orbit much more like infrastructure on the ground, like this building that I'm sitting in right now, rather than some vehicle that that you deploy, use for a while, and then throw away. Our fourth strategic focus area is that of advanced sensors and components. Pete hit on a lot of these, gave you a little bit of a taste of many of these things that we're doing so far, really providing navigation components, solar arrays, deployed structures for a wide variety of missions, whether those be in low Earth orbit, on small satellites, or large satellites in geosynchronous orbit, or all the way out to the moon and beyond, and a wide variety of technologies and capabilities. We're extremely proud to enable missions that span the criticality of national security, Class A missions for NASA and other civil customers, and folks with incredible commercial ambition. And these technologies are critical as we, again, grow the space economy from 6,000 satellites and a few folks on orbit to 50,000 satellites and more folks on orbit in the coming years. Our last strategic thrust area is that of space domain awareness and resiliency. As I mentioned earlier, our economy is increasingly tied to space. And it's critical that we maintain things like the GPS constellation, and we maintain our capabilities on orbit, both from a commercial perspective and from a governmental perspective. Maintaining and protecting those things, knowing is half the battle, and that's where space domain awareness comes into play. We at Redwire are proud to be providing camera systems as well as designing next generation telescopes that can be applied to help monitor the space environment for a wide variety of customers, to make sure that we have the enhanced ability to detect and intercept threats to global and national security. Next slide, please. So, as I mentioned, now we'll walk through just a few case studies in each one of these strategic thrust areas. So first, I'm going to talk about a program in our on-orbit servicing, assembly, and manufacturing thrust area, which sometimes I'll call OSAM. As I mentioned earlier, and as Pete also hit on, we view ourselves as really the world leader in in-space manufacturing and assembly, and 3D printing and manufacturing in LEO and beyond. So there's a few examples here that we're going to talk about. Archinaut 1 is going to be one of them, but these are just vignettes of the incredible disruptive nature of these technologies and of really the brilliance that exists in our team and the ways that folks have seen of how to apply these different technologies. So to talk about Archinaut 1, so this is a mission that we at Redwire are developing with NASA, for NASA. And this is a small satellite, about the size of a dorm room refrigerator, that will launch in 2023 on a rideshare mission that SpaceX is fielding. And when it gets on orbit, it's actually going to manufacture and assemble very large solar arrays that you see here in this picture. Now, normally satellites that are about this dorm room refrigerator size, the solar arrays that they pop out are maybe 6 feet long. But using 3D printing and robotic assembly technology, we are able to manufacture, just on this initial demonstration mission, we're going to manufacture and deploy structures that can support solar arrays that are 10 times larger, which means we can put 5 or 10 times more power on this asset. And power is really, the coin of the realm in space. We've been able to leverage, we as a space community have been able to leverage modern electronics to make payloads smaller, which means that we can make our satellites smaller. But at the end of the day, physics doesn't really care about Moore's law, about our ability to shrink electronics. What we need is more power to put through those things, and for that we need larger surface area, whether we're talking about a small satellite or very, very large assets. So this technology for small satellites, for those satellites in LEO, means that we can put multiple kilowatts of power through a small satellite versus the amount of power that we can put through today with the state of the art. This technology is a general solution, however. We can use the same robotic assembly and 3D printing technology to deploy large antennas, or put out larger radiators on satellites so that they can reject the heat that's generated from a lot of the activities that go on these assets. Looking forward, this technology is, it changes the game in a broad-based way for satellite and spacecraft manufacture and design. I've talked a lot about with Archinaut small satellites, but this, as you can see here in the pictures, large structures are also more capable and more accessible with this kind of technology. Building large telescopes, is without human intervention, is achievable as this technology matures. Now, I could talk about this for literally hours, but I'll spare you that, and we'll go on to the next case study. So the DART mission, this is a really cool mission that we're really proud to be involved in multiple ways. The DART mission is the Double Asteroid Redirect Test, and it's a NASA mission exploring the use of satellites as impactors to redirect potentially dangerous asteroids. So it's literally like a planetary protection demonstration mission. But rather than having Bruce Willis, ride in some unobtainium, space shuttle, we're using this really, really cool satellite that's actually going to go out beyond the orbit of the moon, which is a very, very harsh environment from a radiation perspective, from a temperature perspective. And we at Redwire, as you can see in the slide here, are providing some really critical capabilities. First, we're providing navigation components called star trackers, which enable accurate navigation of this spacecraft from Earth to these asteroids to go, find and impact the asteroid. And secondly, you can see there, this is another application of our, high compaction factor rollout solar array technology. Each one of those solar array wings there provides about 4 kilowatts of power to that spacecraft. And the spacecraft uses an electric propulsion technology, an electric thruster that's actually powered by those solar arrays. So really, we at Redwire were proud to be working with with our customers and our partners here to enable this really, really cool demo that's going out into a really, really harsh environment. Next slide, please. So another area that we're really proud of is that of our camera systems and our core avionics technologies that we have here at Redwire. So just a few, we actually have a wide variety of technology here, a wide variety of assets here, a lot of which are leveraging the latest in COTS, hardware compute and capabilities in a what we call a radiation tolerant way. So applying some of the great smarts and techniques that our engineers and technicians have to make these to leverage modern electronics in these really harsh environments. So two examples of how we're doing that. The first is the camera systems and controllers on the Orion spacecraft. So for those of you that don't know, Orion is super cool. It's a human-rated spacecraft, that's going to take humans back to lunar orbit and ultimately be the ride for folks to return to the moon's surface, as I was talking about a little bit earlier via the Artemis program. We are actually building 11 of the 13 cameras that are external and internal cameras for this Orion spacecraft. And some of these cameras are really, really incredible, and we're proud to be developing them and delivering them to Lockheed Martin, who is the prime contractor on this. And in fact, some of them are these really neat, like orbital navigation cameras that, in the event we lose comms and other navigation tools on the spacecraft, these cameras actually have the ability to take pictures of the Earth and the Moon and determine the orientation of the spacecraft, determine the orientation of that space capsule, and allow it to re-enter, bring those astronauts home safely. So it's a really important part of the overall mission and the contingency planning for this mission. Another program I'd like to highlight is our involvement in the Firefly Blue Ghost lunar lander for the Commercial Lunar Payload Services program. So Firefly is providing commercially a robotic lander that's going to land on the moon, and we are, we're really tickled to be a part of their team, providing both an array of cameras they're going to not only provide really great imagery on the way to the moon and on the moon, but also are part of the vision navigation system for this spacecraft. They're actually going to help, robotically, using machine vision, orient and pilot that spacecraft down and land on the moon's surface. We're also providing, using some of our technology, the core avionics for this spacecraft, for this mission. And these are just a few of the applications of our modular camera system product lines that we have at Redwire. I mentioned a few, earlier, we use systems here for, for space domain awareness and many other applications as well. If we go to the next case study. So this is another really cool application of in-space manufacturing. This is a program where we're actually manufacturing with lunar regolith, or like literally moon dirt simulants. So when Old West settlers went out into the wilderness to build a new life for themselves, they took the tools with them that enabled them to live off the land. In space, it's going to be no different. When we want to go and sustainably live and work on the moon's surface, we will need to bring tools that enable us to use local resources. 7 years ago, we manufactured the first functional objects off the face of the planet by doing 3D printing on the International Space Station. Since that time, NASA, ESA, and others have really come to recognize that manufacturing in space, in particular manufacturing with lunar regolith, doing in situ resource utilization, will be essential to this sustainable exploration of the moon. Providing tools, fixes, structures, and even maybe one day landing pads on the moon can be enabled by 3D printing with lunar regolith. We're proud to say that together with NASA, we're taking an important step in making sustainable lunar operations a reality by demonstrating the ability to 3D print with a lunar regolith simulant, with a moon dirt simulant on the International Space Station. This will be flying, we're actually flying the payload that you see here in the left side of the slide to the International Space Station in early August on NG-16, where then we'll demonstrate the ability to 3D print with lunar regolith simulant, which is really, as we think forward to that fantastic future, that fantastic vision that Pete laid out of space commercialization, industrialization, that's going to help enable this next generation of space exploration. If we go to the next slide. We are particularly proud of our Acorn modeling and simulation product offering. This tool allows users to design, test, and simulate a space mission throughout the design process. Whether you're focused on designing and delivering a large space telescope that's based in geosynchronous orbit, a small fleet of space domain awareness assets, or an entire constellation of telecommunications satellites in low Earth orbit, Acorn enables you to model and simulate your missions at a high degree of fidelity before you cut any metal or before you procure any expensive hardware. This allows rapid and confident design iteration and customization compared to traditional space mission design approaches. Of note, as the design matures, we're also able to integrate components that we've procured into Acorn, enabling hardware-in-the-loop validation and maturation of the design. This workflow enables satellite missions to be fielded faster and be better tailored to our users' needs. And this is critical as customers increasingly seek high technology refresh rates and more responsiveness and lower development and deployment costs. So as we're going, again, from like 6,000 satellites to 50,000 satellites in the future, these sorts of capabilities are critical to enable that to happen in a cost-effective and an economical way. Next slide, please. So to kind of like to wrap this up a little bit here, our space customers require dependable hardware and software. These solutions really need to push the boundaries of technology in order to consistently operate and deliver for them in the harsh environment of space. This is an area that we're proud to say we have consistently been doing for a very long time, and we are proud to have this innovative technology to deliver on this fantastic future vision of space that Pete laid out for you earlier. Whether it be deployable structures, roll out solar arrays, or really power, but ranging from small satellites up to the small satellites, ESPA class satellites, all the way up to the very largest assets in space like the International Space Station. We at Redwire are proud to be a trusted mission partner to a wide variety of customers. And as our government and commercial customers continue to push the envelope, continue to deploy more, we're really excited to be continually chosen by them to be a part of their most challenging missions. So with that, I'm going to turn it over to my friend Mike Snyder, our Chief Technology Officer, who, as Pete mentioned earlier, is really the godfather of in-space manufacturing and literally the inventor of a wide variety of the in-space manufacturing and 3D printing technologies that I was just describing. So, Mike?
Thank you, Andrew. So, pleasure to talk with you all. Mike Snyder, CTO. Prior to this, I was a founder of MainSpace, which brings us to this picture. This was actually one of our first flights we did in parabolic aircraft about a decade ago, and I'm floating there more ways than one, mentally and physically. We're testing out hardware, and that actually is the foundation of kind of everything we're doing on the OSAM front currently. And I'm going to step you through kind of our IP process as well as kind of how we do programs in general, and not jump to the building the house, but first build the foundation for the house. Next slide, please. So to start off, kind of just talk about our robust IP portfolio and how we protect things. We like to build multiple moats around our IP castles for our key areas. We have over 60 patents are already issued, and we have hundreds of applications going onto that. So we not only protect what's in the near term, but we also protect things that are down the road. And that's part of our ongoing development and protection strategy that we lay out. So we meet regularly to try to understand what's protectable, how we protect that, as well as how we develop that further to get the maximum amount of protection out of that intellectual property. So currently we have some seminal technologies that we have patents on, including microgravity manufacturing, additive manufacturing, assembly of very large structures, remote operations of those devices and other devices, space-based manufacturing in general, as well as deployable space structures. So kind of going on the right side there, these are all of our industry firsts that we're very proud of. And just to also say, this is an abridged version of our disruptive technologies. Probably could talk to you about this for weeks. So we were the first additive manufacturing technology to operate fully in microgravity. We also are the first and only commercial manufacturing facility up there that you can call right now. We can print some parts. For you. NASA calls up and may need a part for something that they don't send up. And that's a fun kind of weekly thing we do. We're the first 3D printed ceramic parts ever made off Earth, as well as the first to produce optical fiber manufactured in space. We've grown crystals for the photonic industry in space, and we're the first to do that. Also, we've been working on recycling capabilities, and we're going to be the first spacecraft that builds and assembles part of itself, which is pretty exciting. Next slide, please. So these are the 3 kind of broad areas that I'll be talking about today. First is space-enabled manufacturing. That is kind of our core in terms of looking at the future, because it embeds all of our heritage products as well as all this advanced technology that we're developing. So we're working on things through Archinaut and other programs that are working on polymers, ceramics, composites, and metal manufacturing of structures in space, as well as the assembly of complete subsystems and systems in space. Through advanced robotics with our Stark robotic arm, as well as the software that kind of monitors and drives that process. So we work with a lot of machine learning and machine vision, and that is great because we can use our own advanced camera systems for that to assemble things in space. And we've proven that out in a thermal vac, which simulates the vacuum and pressure, or the pressure and temperature environment of the space environment. Next thing would be in situ resource utilization. How do we go from RV camping trips that you're not even building fires using local resources to complete settlements and sustainable settlements that you don't need resupply from Earth. And then last will be advanced materials manufacturing. We actually leverage the microgravity and thermal vacuum environment as a resource. Instead of designing around it and mitigating it, with these payloads, we're actually designing how to leverage them for viable products that are profitable once launch and return is considered. So it's very exciting things. And on that front, we have a couple of things in the future that's launching relatively soon, including a freezer capability, something that produces metallic superalloys. And we have continued investigations with our industrial crystallization facility and ceramic facilities. Next slide, please. So right now, Andrew touched upon this right now with on the current paradigm. You're basically designing something that lasts 5, 10, sometimes 15 years to survive the first 10 minutes of its life, which is, astounding. And a lot of the mass of the vehicle, the end vehicle, comes from supporting that launch environment. So with this type of capability in terms of on-orbit manufacturing and assembly, you can actually make very large things with the same amount of mass, or reduce the mass significantly of the capabilities that are being launched today, which means you can make a cheaper mission, go on a cheaper launch vehicle, or launch multiples of the same thing on one launch vehicle. So we like to think about this as you build structures in space that can't even survive the gravity on Earth. And that's kind of how you optimize this environment. And we're doing this through the Archinaut program, as well as the Archinaut-enabled technologies, including the composite and metal structures that we're developing internally. This also allows huge, massive things to be built. And that, once again, Andrew touched upon the power generation capabilities, but also from a communication standpoint, that is important. So what it really comes down to is launching raw materials, manufacturing components on Earth, and then assembling them. So right now we're working on a very basic, structure manufacturing capability that then makes power systems. In the future, these satellites will basically become transformers. You'll be able to send up instructions, and they'll be able to modify themselves, or we'll send a servicing vehicle to them to transform it for what they're needed. So imagine a telecoms dish that no longer is serviceable for its environment in terms of what it's looking at on the ground. You can actually reconfigure that satellite to service a new market without actually having to launch a new asset. So with that kind of in mind, you're looking at a paradigm where you're launching raw materials, and you can almost determine what your end mission state is as you're having your mission. And that's also through the digital engineering environment. We can simulate what that's like without ever having to test it on the ground, and then implement it on orbit eventually, which is pretty exciting. Next slide, please. So this kind of all builds upon a foundational heritage of hardware. So once again, we didn't just start to build the house, we built a foundation through technologies that are feasible and functional on orbit today. So we started with additive manufacturing and really advanced that capability quite substantially. Then we progressed to vacuum manufacturing with the same hardware we're using with our additive manufacturing facility. And then with subsets of that hardware, we started building extended structures. So we kind of went from A to C through a logical technological path, which enabled us to do this in a affordable sense and in a timely manner simultaneously. So then we start building up our capabilities for robotic assembly. So we tested at a thermal vac environment using our machine vision and learning algorithms to take parts that were manufactured and put them together. So what does that enable? Well, in the near term, you're talking about things like our Optimus SCI project, which is a long interferometer that's space-based. So right now, that for astronomy, you could take pictures of exoplanets when the baseline gets long enough, and that's pretty exciting. Even 1 pixel of an exoplanet can give us an amazing amount of data. Similarly, you can turn it back and look at things on Earth with pretty high angular resolution. And Archinaut is an example of how we integrate our current heritage when it comes to solar arrays with the future of extended structures. So right now we have solar array offerings from small sats all the way up to the International Space Station. And with Archinaut-enabled technologies with that heritage, now we're talking about any system you can think of to come, including enabling space solar electric propulsion in space, which has been an exciting want that the engineering community has been wanting for some time now. And then next gen, you're talking kilometer scale structures, very large things that right now in terms of the space world, it's not really even a conception for most programs. We can build large reflectors to increase gain on assets. Another thing we could build is orbital base stations, which imagine a satellite that you just put the payload up, and there's already a structure to stabilize it and power it and communicate to the ground with it. So the satellite payload is all that's being plugged in, and you can do these large structures. And then also next generation defense satellites. So building things that are kind of an on-demand environment where the mission could be changing regularly due to an adversary, and sending the instructions, having it modify on the go, and that's kind of what we mean by that. Next slide, please. So this is kind of a fun one because to get to that fanciful future where we're building humongous things, you don't want to launch it all. Currently, we take everything with us, and including raw materials, and we manufacture that way. And in terms of human missions, we take everything we need with us and all the contingency supplies that you need as well. So eventually, we need to get to what we actually have on Earth, where if you need something, you use the resources around us. There's no drop ship in space sending things across the country or even interplanetary. So you need to get to a point where we're building everything in situ, taking local resources, refining them, and that includes building supplies as well as human consumables like oxygen. So right now we're working this awesome thing on the ISS, which is taking Regulus Simulant, which is basically mechanical analogs to what's up there on the moon. Al Roker was stepping in it a couple months ago at NASA Glenn, and we use that with a binder and basically build up structures to prove its impact in space, because things change between a 1G environment and on the moon's a 1/6 environment. So if we test out in a 0G environment, we kind of have the lay of the land on what could happen. So this is kind of proving out this technology, which we want to eventually use for these great possibilities of tomorrow, which is near-term building landing pads, structures for bases, and key structural elements inside the bases. Down the road, we want to build a self-replicating system. So we want to have von Neumann machines going out there, collecting resources, rebuilding themselves, because if you have that capability, you can build anything. Obviously, that is not our near-term objective. We're far away from the Star Trek replicator also, but we're building a pathway to eventually get there, and doing it in ways that people actually are demanding the technology for their missions currently. Another thing is eventually, you won't actually need to send anything besides data for these missions, which is pretty exciting. Next slide, please. So right now, I just want to touch upon these two payloads. We identified a lot of product areas that we think are profitable through processing in microgravity. ZBLAM was the first, so it's an optical fiber that reacts differently when it's formed in microgravity than it does on the Earth, and it's been proven to react differently. So we've produced that. We've launched this payload several times. We've gotten awesome amounts of data, and we're stepping through from where we're at now with understanding the basic principles of the fiber pulling process in microgravity to eventually building full mechanized autonomous facilities up there that will just build or will pull fiber and then send it back down to Earth. But we have to understand how to get there in order to minimize the risk as well as maximize the fidelity of the product. So that's kind of what we're doing there. We're also building photonic crystals on the industrial crystallization facility. We've finished our first round. It's coming back soon, so we'll have some cool results. And based on the images, we'll have some cool results. And we're going to launch that several times with different materials to see how they form. So there's definitely some areas there where we identified of some interesting materials and how they're affected by the microgravity environment. Also, we've also launched our advanced ceramic facility, which has come back, and we've shown that it does change the processing in microgravity in a positive way. And we're going to launch that again to further develop that product, which can be used for our initial product that we're developing is for turbines, which can be used for aircraft, power generation, and just regular engines. So it's a very exciting facility, and we're also launching our superalloys facility this year, which will do the metal version of this and focus on those type of materials. So with that, I will pass it over, next slide, to Al Tadros to go over who we serve.
Great. Thanks, Mike. Appreciate that. Good morning. I'm Al Tadros, Chief Growth Officer at Redwire, and I'm very excited to be part of the Redwire team sharing our story with you today. This cover shows NASA's Parker Solar Probe being lowered into a thermal vacuum chamber. This is the first ever mission to touch the sun, flying through its atmosphere multiple times. Redwire provided the unique sun sensor that helped navigate this mission to the sun. So we're extremely proud of what we do and passionate about our customers and our missions that we serve. I have 30 years of industry experience through SSL and Maxar, including 10 years as Vice President for U.S. government business development there, growing the new business pipeline. So I was thrilled to join Redwire last year as Chief Growth Officer to organize and equip the business development, government relations, and Marcom team for the rapid and sustainable growth that you're hearing about here today. Next chart, please. So let me talk about serving our large and growing market. As you've heard multiple times and in multiple forums, the space market is sized at about $420 billion as of 2019, and expected growth to $2 trillion plus by 2040. This is across multiple markets. One of the catalysts for this growth is the significant reduction in launch costs, as well as the increased options in small and large launch vehicles and frequency of access to space. Simply, transport to space is becoming more available now to more missions, and that enables missions, not just the existing missions. So this is one of the catalysts for the rapid growth that we're seeing. Redwire is fortunate to be serving commercial communications and Earth observation missions with antennas and attitude control sensors. We're supporting human space flight missions with cameras and related equipment that, of course, has to be human safety rated. We provide mission critical payload adapters for a variety of launch vehicles. We're a trusted mission partner for national security missions, including large deployable booms and structures. One example is the Rosa solar arrays that you saw earlier. So part of our customer set, we're serving NASA and other space civil space missions with critical technologies like the advanced deployable solar array, and we're working with internationals and commercial markets to deploy robotics, which are enabling more missions. So we're well embedded and proven partner across all these markets. Also across all these markets, we are developing significant and unique innovations like Mike just described, including in-space assembly, servicing, and manufacturing, like 3D printing. Much of these developments are in partnership with and funded by our customers. So we have the benefit of working with our customers to develop their next generation technologies and then deploy them in an operational environment. Again, with the reduced costs and more frequent access to space, we're really excited by the new missions and services our customers are funding and deploying. Redwire is well positioned in the highest growth verticals of these markets, like OSAM. Innovative solar arrays for high power and volume efficient packaging of and small satellites. So we serve whether it's high power habitats or proliferated small satellite constellations. We're able to enable and serve those markets. Next chart. We're proud to have a diversified base of current blue chip customers with significant mission histories and growing mission needs. We do trusted work with the US government and have facilities and staff to do classified work across multiple locations. We have tremendous civil space footprint in working with some of the world's leading scientists and across amazing missions to explore the solar system, sustain human presence in low Earth orbit, employ space-enabled manufacturing. We have years of experience delivering and operating payloads on the International Space Station, and we're translating that experience to support humanity's expansion in space through NASA's commercial LEO destination and Artemis programs, as an example. Similarly, Redwire has been serving the commercial space market and understands their cost structure and schedule critical mission development. We understand the commercial space environment is different than government-funded and government-led space programs, and we've demonstrated our ability to serve that market. An exciting example, we're providing our cameras, processing, and machine vision for autonomous navigation and obstacle avoidance for the Firefly lunar lander mission. This is a contract vehicle that NASA put out called CLIPS, or Commercial Lunar Payload Services, that delivers NASA payloads to the surface of the moon. NASA's not directing the design and development of these landers. They pay for the service of the payload delivery. And we're fortunate to be part of Firefly's team in delivering a hugely technical and hugely capable navigation and landing system. Again, we enjoy long-term relationships across government and commercial space sectors with on-orbit successes, which is so critical in this industry. Next chart. Our growth pillars includes a platform approach where we cross-pollinate between legacy business units, and we are able to continue doing so as we grow through acquisitions. Ours is a very technical and relationship-driven industry, as you all probably know. Understanding the technologies and how they serve our customers is critical. We maintain the BD talent at the business unit level while using a small core business development team across Redwire to coordinate, execute on large efforts, pursuits, combining capabilities from across business units. So we sustain the growth that the businesses were already on, and then we combine them with other business units on targeted opportunities, and are able to serve our customers at even a larger scale. Our extensive heritage and our extraordinary innovation are the engine of our organic growth. So We don't rest on our laurels. We have extensive heritage, but we understand the industry moves and moves rapidly, new services, new missions, and we're part of that equation. We're thought leaders, we're technology developers, and we're great mission partners. We've staffed our growth team with industry leaders like Dean Bellamy, who's a demonstrated industry leader in DoD and intelligence community. He's our Executive Vice President for National Security Space. Dean is a retired colonel from the U.S. Air Force and came to us from Peraton, where he was Vice President for space strategy and led the growth in the U.S. government business there. Tremendous patriot and colleague and friend. Similarly, we had the pleasure of bringing Mike Gold on as Executive Vice President for our Civil Space and External Affairs. Mike came to us from NASA, where he was Associate Administrator for Space Policy and Partnerships. Previously, Mike was, before he went to NASA, he was the Vice President for Civil Space at Maxar and helped the growth there, and that's where I got to know him. Again, this is a relationship business, both with customers, but also with colleagues, and Vice President for space strategy and led the growth in the U.S. government business there. Tremendous patriot and colleague and friend. Similarly, we had the pleasure of bringing Mike Gold on as Executive Vice President for our Civil Space and External Affairs. Mike came to us from NASA, where he was Associate Administrator for Space Policy and Partnerships. Previously, Mike was, before he went to NASA, he was the Vice President for Civil Space at Maxar and helped the growth there, and that's where I got to know him. Again, this is a relationship business, both with customers, but also with colleagues and partners. So a tremendous team, very experienced team that's both forming the organization, the business development organization, but also accelerating the growth as we acquire and grow. Finally, as you've seen, we're rapidly growing through acquisitions of leading entrepreneurial companies. A key reason we are attractive to established and credible small space companies is the team that we have assembled. With our wealth of industry leaders across the businesses that we acquire, we've already acquired, we're able to attract and collaborate with founders of other businesses who are aligned and want to join our exciting company. So this is a combination of great elements for growth. Next chart. So our approach to continuing a market-leading growth. First, we have a solid foundation of $280 million in backlog. Bill will go over the financials later, but for business growth, this means we have customers that trust us and depend on us. This is proven momentum we are springboarding off of. Nothing helps new business like having business. We're focused on eminent and large-scale space programs. U.S. government is the #1 customer across the globe, and we understand and have a close finger on the pulse of where the large programs are going. Whether it's proliferated LEO by the DoD Space Development Agency or NASA's Artemis program, we have a strong and enabling role with our customers. We are also thought leaders and innovators. As you've heard, we're developing new technologies. As you heard from Mike Snyder and Andrew, we're developing new technologies that will accelerate our customers' new architectures. So the future is not just the services and missions that we've seen, but the new missions that we'll be able to work with our customers to enable. Finally, this growth was started and continues through acquisitions for Redwire. It's exceedingly exciting to be leading a growth team that is regularly adding new talent and technology. We're structured to both acquire new businesses and to integrate them efficiently into our platform. We've demonstrated the speed with which we can grow through the 7 acquisitions over the last dozen months or so. And in this way, it's hugely exciting to be talking with like-minded colleagues and friends as we discuss the potential to acquire and to bring them on board. All this combined supports our financial growth and trajectory, which Bill will detail shortly. Next chart. So along with our solid $280 million in backlog, we have a robust pipeline. I wanted to share, across our pipeline, we have over 170 million of submitted bids that are currently in evaluation by our customers. That's over 170 million in that category. Another 50 plus million in bid process now, where we're writing the proposal or the bids to our customers, and that are being submitted shortly. So combined, we have over 500 million in total backlog and near-term revenue potential in our pipeline. Beyond that, in early leads and qualified and early capture, we have a tremendous pipeline across the customer sets that we've described. So with that, hopefully that describes some of our org structure, our plans for growth, and our method of growing. And I'll hand the floor over here to Faith Horowitz, our CAO.
Thanks, Al. Good morning, everyone. I'm Faith Horowitz, the Redwire Chief Administrative Officer. As Pete said, I have over 30 years of business management experience, and over these years, I've been part of the management teams of several high-tech startups that we grew to successful businesses. In 2007, I founded my own company and sold it 11 years later to Polaris Alpha, where Pete was the CEO, which is where I first had the pleasure of working with him. And now I'm pleased to be bringing my management experience to the exceptional team at Redwire. Now, I want to take a moment to point out to you the picture on this slide. It's a picture of some of our amazing engineers and manufacturing team members in Goleta, California, standing in front of the IROSA solar arrays before it was being packed for launch to the International Space Station. I know you can't tell because their faces are all covered with masks, but I can assure you they're very proud of their accomplishment. So throughout my career, I've worked with smart and talented people like the ones you see in this picture, finding them, hiring them, motivating them, rewarding them, and retaining them. They've been the reason for the success of my companies over the years, and they're definitely the reason for Redwire's success. Redwire is a company of entrepreneurs and innovators, and the focus of our people programs is to allow them to succeed at doing what they do best, accelerating humanity's expansion into space. Next slide, please. So this slide gives you a sense of the technical talent that we have throughout the Redwire organization. We have a highly educated workforce with a high percentage of advanced degrees. And as you can see on the right, our workforce is also highly technical. 82% of the workforce is in operations and engineering, with specialties in aerospace, mechanical, electrical, thermal, and software engineering, and in high-tech manufacturing. To maintain that technical cutting edge, we partner with local universities on teaming and joint research. We also support space-based fellowships to further reach our target recruitment pools, such as the Z-Factor Fellowship, the Brooke Owens Fellowship, and the Matthew Izakowicz Fellowship. These fellowships provide access to highly qualified college interns, as well as allowing us to focus on recruiting women and diversity candidates. Next slide, please. So Redwire is committed to attracting and retaining top technical talent. We do have an advantage because Redwire offers exciting opportunities to work in a cutting-edge field that holds the promise of humanity's future in space. These factors contribute to making Redwire an employer of choice in the space industry. To reinforce this commitment to attracting top talent, Redwire has established highly competitive compensation, bonus, and benefits programs. But other factors that attract our talent include professional development and opportunities for continued education. At Redwire, we're intensely aware of the need to grow our workforce. We have built a strong recruiting function that has resulted in 140 hires in the first half of 2021. And because you can't start building an educated talent pool too young, Redwire is also engaged in local programs to support STEM education. You can see some examples of our involvement listed here in the bottom of the slide, specifically supporting school districts, community college, and university programs in space. One of my favorites is the fact that Redwire-space is the primary sponsor of the Colorado Aerospace STEM magazine, which is sent to over 55,000 K-12 students, educators, and school administrators in the Colorado school system. Next slide, please. So one of the reasons Redwire is able to build a national recruiting effort is that we have offices located throughout the country. As you can see here, we have a total of 225,000 square feet in our facility portfolio, with offices located near key customer and university sites. As you know, our headquarters is in Jacksonville, Florida, along the Space Coast. We also have 4 offices in the Colorado Space Corridor, primarily in Denver and the Denver-Boulder area. We are also located outside of Boston in Marlborough, Massachusetts, and we have offices in Albuquerque, Huntsville, and Southern California. And just to make sure we've covered all the time zones, we have an office in Luxembourg where we work with the European Space Station as well. Next slide, please. And as I showed you in the last slide, Redwire has 225,000 square feet in facilities nationwide, but it's not just offices and cubicles. Redwire has invested significantly in the facilities and the equipment that supports our design and manufacturing technologies. Pictured here, you can see some of the labs that we have located across the country and highlights of some of our key capabilities. These include a 3-story high bay for solar array production, class 100,000, 10,000, and 1,000 rated clean rooms, robotics labs. We have custom designed solar simulators to design our products for deep space exploration. We have environmental test capabilities to harden equipment for operating in space, and highly specific 3D printing, as you have definitely heard from Michael Snyder. 5 of our facilities are AS9100 certified, which, as you know, is the quality assurance standard for aviation, space, and defense. And we even have a communication control center that allows Redwire to communicate directly and visually with the International Space Station. Next slide. And now to bring it all home, we have Bill Reed, our CFO, who will make you sit up in your seats with his dynamic financial presentation.
Thank you, Faith. As mentioned previously, my name is Bill Reed, and I am the Chief Financial Officer of Redwire. The picture that's shown on the presentation here is that of our advanced manufacturing facility that both Andrew and Mike spoke about earlier. This facility has manufactured over 200 parts for the International Space Station over the last decade and continues to build parts on a regular basis for our astronauts in space. I'm truly fortunate to have the opportunity to work with this team of individuals. They are an exceptional group, and I think they did an amazing job of telling you what we do and how we are changing space, and why Redwire will win as space wins. I'm going to do my best to try to pull it all together for you and walk through some of the key items in our financial projections. Next slide, please. On slide 50, I'm going to cover some of our business model highlights. We see Redwire as truly unique in emerging growth space companies in that we have that flight heritage that Pete talked about. We have a history of revenue generation and of significant growth. We are profitable today, and we are cash flow positive today. We have mission-critical technology that's currently supporting increasingly larger and larger major programs across a broad customer base of civil, defense, and commercial marketplaces. Because of our broad market acceptance and customer relationships, we are largely winner agnostic and are extremely well positioned to team with program integrators on very large major programs. Page 51, please. This page brings the uniqueness of Redwire home and reiterates the points that many of our team members brought up earlier. Our 5-year projection is based upon a robust $23 billion pipeline of several hundred uniquely identified opportunities that have been factored based upon our estimates of the probability of our ability to meet the program requirements, the likelihood that the program will move forward, and our ability to capture that work. As an example of our $1.4 billion revenue projection for 2025 is underpinned by an $11.4 billion unfactored pipeline of opportunities. To reiterate, we are profitable today. We are cash flow positive today. We believe space is going to be a winning platform, and therefore we believe we will win when space wins. We have a breakout growth story, and it's underpinned by a real, strong, visible, and growing opportunity pipeline that Al talked about. As a reminder, these projections are purely organic. They do not include any assumptions for future M&A. Next page, please. As Al mentioned, we have an exceedingly strong backlog to work from. We're unique to relative to our other new space companies that are coming out today. We have that flight heritage, we have an existing revenue stream, and we are profitable today and cash flow positive today. We have a strong foundational backlog to fuel our exponential growth as we progress to a $1.4 billion revenue company with $250 million in EBITDA by 2025. We define total backlog as the sum of contracted backlog, contracts currently under negotiations, and additional amounts required to complete active program scope in excess of the currently contracted amounts. We have only disclosed our contracted backlog in our previous filings, which represents the future amount of revenue to be recognized on awarded contract amounts in hand. That's the $158 million amount represented in red on this chart. The strong level of total backlog gives us a great deal of conservative confidence in our future revenue projections. Slide 53, please. Again, emphasizing the uniqueness of Redwire, we aren't a one-trick pony. We have a broad breadth of enabling technologies that allow us to be that picks and shovels company that Pete talked about that's going to support this new space gold rush. We are projecting our revenue to grow from $163 million today to $1.4 billion in 2025. As pointed out by the team, we have a broad portfolio of enabling technologies required for the missions today. Al mentioned that we have in excess of $500 million of revenue visibility for the next several years, and that's driven by a combination of our total backlog of programs and programs that we are bidding on or our customers are currently evaluating the bids that we've already submitted. These opportunities that we're executing on today and that we are working on include, but aren't limited to, many applications of our patented rollout solar arrays, camera systems that Andrew spoke about on the Orion and other spacecraft, lunar lander control systems, and many, many other opportunities. The combination of our various technologies is dramatically expanding our involvement in large, major new programs, including many opportunities within the Artemis program, the return to the moon, the return to voyages to Mars, digitally engineered constellations, as we see the population of satellites in space growing from around 6,000 today to a projection of more than 50,000 over the next 10 years. And we believe we were uniquely situated to be a key player in the new national defense space architecture. As Mike discussed, we are a leader in disruptive 3D printing and advanced robotics technologies that are creating new markets in space and beyond. These include OSAM, manufacturing in space for both Earth and space, and space as a service and lunar infrastructure. The $1.4 billion, as I mentioned, does not include any assumptions for M&A. However, we do see additional opportunities for significant growth coming from strategic investments, both internally and through focused and responsible mergers and acquisition activity. Next slide, please. Slide 54. As we have mentioned, Redwire is profitable today, but we see a multitude of opportunities to grow our margins going forward. We have assembled a world-class management team with decades of experience in both public and private companies. Many of us have made our bread and butter by making good companies great. By applying this management know-how and experience to several businesses that have been small, family-owned, and limited in resources, we open up nearly unlimited possibilities to improve pricing, program management, and contract negotiations. Many of our businesses are moving from historically R&D and proof of concept programs to real-world repetitive applications of the concepts with stronger margins. We believe that Redwire is a 1 + 1 = 3, 4, 5, or more type organization. As we bring these diverse enabling technologies together as a one Redwire offering, our value to the customer base expands exponentially and opens up program opportunities that any of the individual predecessor companies could never have attacked on their own. There's an old saying that volume solves all problems. That may be a little bit of an overstatement, but it's definitely true that Redwire has excess capacity today. We have invested heavily in overhead and corporate G&A early, including the requirements to be a public company, so that we can leverage our growing revenue to grow without growing our fixed and semi-fixed overhead structure and yield improving margins as we move forward. These economies of scale will apply to both the utilization of our fixed plants and the leveraging of overhead and G&A. Finally, our various parts historically have relied heavily on third-party subcontractors for specialty engineering, testing, and for legitimacy on larger contracts. As a combined Redwire, we have many of these capabilities in-house today, and we are starting to keep that subcontract profit at home and grow our margins. Slide 55. Our pro forma Q1 results are in line with our expectations and demonstrate the continuing growth of Redwire. Pro forma revenues are up 27% compared to the same quarter for the prior year. We expect increasing revenues throughout the year that are expected to leverage our relatively fixed operating expenses and drive improving margins throughout the year. I will note that our pro forma results include the acquisitions of Oakman and Deployable Space Systems as if they were part of Redwire as of January 1 of this year and for the comparable period 2020. That yields the variance between our pro forma numbers of $36 million for revenue versus our GAAP numbers of a little under $32 million for the first quarter of 21. And with that, I will turn the presentation over back to Mr. Canito for closing comments.
Thank you, Bill. All right, well, that concludes the prepared portion of our presentation today. I'm very grateful to all you for attending. I will leave you with these investment highlights. We're a pure play space investment company with scale, and as I hope we demonstrated today, we are at just the beginning of a historical economic expansion in space. And with our heritage plus innovation strategy, Redwire is extremely well positioned to grow along with the space industry juggernaut that will unfold over the next decade and beyond. We're very proud of what we're doing. Hopefully the passion was conveyed. The one thing that unfortunately you cannot convey in a set of slides is the passion and commitment that the Redwire employees bring to work with them every single day. I am constantly humbled by the extraordinary work that they are delivering. We're honored with the just critical missions that our customers entrust with us, and humbled by the extraordinary work that's happening in space right now. We're very committed, but we like to have fun too, and we are developing as a young company a really extraordinary culture, and that's a big part of who we are today and who we are in the future. And we are confident that we will play a critical role in the future of space because we are delivering today and we have been delivering in the past since the very beginning. So with that, I'll turn it back over to our team here, and Mr. Jonathan Bailiff from our partnership at Genesis Park is going to handle the Q&A.
Thank you, Pete. So we have been receiving questions over the website. I want to remind everybody that you can submit your questions. Currently, we do have a significant number, Pete, and the rest of the team. I will be a bit of the MC in reading those questions, to the team. I will try to get at least one to maybe one follow-up question, and then try to get through as many different individual retail investors, but also a number of our institutional and sell-side investors also. And with that, let's begin. We're going to begin with a retail investor. Ryan Cohen asks, what do you see as your role in the continued adoption of commercial space stations from companies like Axiom Space, Sierra Space, and Nanorex?
Great. Well, thank you for that question. I love that we're starting with a technical question. So yeah, we're extraordinarily excited about what's happening in commercial space station with the companies you've mentioned. You hopefully have seen the press release that our partner Sierra Space put out about the MOU between Sierra Space and Redwire. We believe that Redwire has the critical capability that is going to populate virtually any commercial space station is deployed. We do provide that critical infrastructure for the space stations themselves. But in addition to that, when you think back to some of the technologies that Andrew talked about, when you think about the extraordinary technologies that Mike Snyder laid out, these are the things that give people a commercial purpose for being in space. So we're very excited about anybody that wants to put up a commercial space station because we're confident that they will be populated with Redwire payloads to include our on-orbit advanced manufacturing, 3D printing, whether it be ceramics, fiber optics, metals, or whatever. Commercial space stations are a huge tailwind for us, and we look forward to partnering with all those organizations that were mentioned. Andrew, is there anything you'd like to add to that?
Yeah, I mean, I think you really hit the nail on the head. There's probably three general ways that we view, that we view us as players and involvement in that. First is just the full-throated support for these folks, right? What Fatih's doing at Sierra Space, what Mike Safranini's doing at Axiom, what Jeff Mamber's doing with Nanorex, it's awesome. The second is that we are excited to be a trusted mission partner to these folks and provide, whether it be power systems, avionics, or other engineering support. We want to help field these capabilities. That third is providing that capital equipment, providing the things that go inside and are used and fill these these kind of industrial parks in space. That we view ourselves as really synergistic there. On a more personal note, longer term, I hope to take a vacation to these places in the future because that's another really critical part is the expansion of folks going to space and living and working in space.
Excellent. Yeah, space is truly a team sport, and when these guys win, we believe Redwire will win with them. So thank you for that question. Jonathan, back over to you.
Next question from Austin Mueller of Canaccord Genuity. Can you compare and contrast the capabilities of your Archinaut with the Northrop Grumman MEV?
Okay, that's a good question. I'm going to turn that one over to Andrew.
Yeah, MEV is a really amazing vehicle. It's a servicer vehicle. The first vehicles that have gone up, they maneuver up to an asset and they kind of harpoon and dock with it, and then provide almost like a booster pack that provides navigation and control for these assets to extend their lives, where maybe they're close to running out of fuel and continue to operate. Which is it's really that definitive demonstration of servicing on a larger scale. Archinaut contrast that with Archinaut, which is more focusing on the actual manufacturing and initial deployment of assets on orbit. So rather than taking an asset that was optimized to survive launch and then deploy, but extending the life of that, Archinaut's more focused on that assembly and manufacturing aspect of optimizing for the space environment. There are a lot of really interesting ways that we are, again, we're synergistic, and space is a team sport, and we kind of we can work together. In the future, as servicing capabilities become more advanced, the 3D printing, manufacturing, reconfiguration, assembly capabilities that we are developing and demonstrating with Archinaut and our broader OSAM portfolio, fit hand in glove with a servicing architecture like Northrop Grumman's Space Logistics entity is now taking those first steps, doing that crawl, walk, run with MEV.
Yeah, that's great. I totally agree. There's a vibrant, emerging on-orbit servicing capability that Redwire is a critical part of.
That's right.
We see the continued maintenance and sustainment of these on-orbit constellations as a big part of where 3D printing can play a role, as Andrew said. And in addition to that, our capabilities, such as the robotic arm that we've had developing, is a key piece of infrastructure that a lot of these capabilities, like the MEV, like the great work that our partner Momentus is doing, who selected our robot arm as part of their in-service space capability, that we have those assets that are going to help enable that too and be a big player in that rapidly growing field. Thank you.
We're going to let Austin have one more follow-up here. Can you describe what portion of the iROSA is built by Redwire versus the prime contractor Boeing?
That's a great question. So the entire mechanism, the iROSA wing itself, is built by Redwire, but I'll let Andrew talk to the details of those mechanisms and how we build it.
Yeah, absolutely. So the core ROSA technology, that core rollout solar array technology, is Redwire's patented, developed technology. And so not only on iROSA, but on missions like DART, on Ovzon 3, and other missions that we're working with customers on, that core solar array technology is our intellectual property and is built and integrated in our really, really cool facilities in Goleta, California. We naturally, in working with customers that have a broader mission, there are parts that they do that we integrate with. And so, our teams work really, really closely on iROSA with the team. It's really, almost in a badgeless fashion, right? Like, that mission is a mission that we, together with Boeing, we're proud to, and continue to be proud to deliver for our ultimate NASA customer. There are parts like the kind of adapter structure that Boeing, and their just incredible experiences as the prime contractor for the ISS. They built and made sure it was going to be safe for the astronauts. And then we, like I said, integrated the large arrays, and actually Faith showed a great picture of it with the team there standing in front of it in our facility.
Excellent. Yeah, absolutely. The partnership with Boeing has been really great, and our customer NASA as well. Again, nobody can go it alone, totally in space. Jonathan?
Great. Let's go to Greg Conrad of Jefferies. When you think about the different strategic areas for Redwire, are there any specific elements that stand out as growth leaders?
Excellent question. So, clearly the 5 strategic focus areas that Andrew highlighted in the briefing is an important part of where we are. But the portfolio effect of our technology is equally important. I like to say, as I said in the brief, that we have a blue chip foundation with venture optionality. Things like the iROSA technology, things like our machine vision capability, our digital engineering, our in-space manufacturing. These are all that venture optionality that gives us the opportunity for extraordinary above-market breakout growth. However, we're not dependent on any single one, and that's important to our strategy. We're here to operate in space for the long term, and that means continuing to innovate and continuing to work through all the fast-moving growth streams, if you will, in faith, so, or in space. So although we do have those 5 strategic focus areas where we're putting a large portion of our time and money in terms of investing for the future, we do have that broad set of product capability that prevents us from ever having a single point of failure in the marketplace.
Great. Let's go with a retail investor. Mano, again, I didn't apologize, but I will now if I don't get your name perfectly right. Mano Van Nguyen. With the money from the going public, merger with Genesis Park, the plan is to acquire more companies, right? Are there already plans in progress? Does Redwire have a number of acquisition partners that they're looking at? That's I'm assuming his question.
Yeah, I understand. So one of the extraordinary things about our proven past performance to date in successfully executing the acquisitions, especially the fact that, as I pointed out earlier, the founders that were materially involved in the businesses when we acquired them have taken on critical roles in the go-forward Redwire, is we've created somewhat of this virtuous cycle through that network of founders. Founders talk to each other. Founders have broad networks of other founders that they've been working with throughout the years, and that has created this virtuous cycle of introductions, people coming to us as well, seeing what we're doing, seeing where we're headed, seeing our unique culture, and wanting to be a part of that. So we intend to be highly acquisitive going forward with the SPAC proceeds, and we have a very robust pipeline of opportunities. I'll point out that the vast majority of our opportunities to date have been sourced in a proprietary nature, and that again is part of that competitive advantage of having this founders network that has developed through our success to date.
Great. The next question comes from Ted Sohn from Platinum Milestone Investors. Regarding the MOU with Sierra Space, does this mean that Redwire and Sierra will work together to bid for commercial space stations development? What is the benefit for Redwire for this MOU?
Yeah, we don't comment on any particular procurement strategy, but what I will say is that we work very closely with Sierra Space on a number of fronts. We are certainly aligned with a collective vision for working together into the future. We recognize that they have extraordinary past performance in space, particularly with their Dream Chaser capability, as well as other emerging capabilities that are in development. And they recognize that Redwire is the industry leader in on-orbit manufacturing and payloads for future space commercialization. So that I think you're going to see really great things emerge from our two organizations working together.
Ted has a follow-up, so I'm going to, any plan to mass produce Z-bland or other valuable substances in space? Any possibility to sell Z-bland production or facility to other manufacturers? I mean, is there any way to make, in essence, more money from this? What is the business development for actual space manufacturing about these substances that will come back terrestrially?
Again, we're not going to comment on the specifics of our strategy associated with any one production line. But again, we are one of the early movers in partnering and proving out the economics of the Z-bland capability. So it is one of a number of different capabilities that we are looking at for future economic production in space. And that is really the critical takeaway, is that we're not only learning things as kind of a pioneer in space commercialization from a technical perspective, we are laser focused on the economics and how we can actually make it become a viable contributor to the terrestrial economy. And that's an area that we have a lot of experience in, and Z-bland is an area where we've put a lot of thought in. I don't know, Andrew, if you want to add anything to that.
Yeah, I mean, just to table set a little bit there, we've actually manufactured Z-Blend in space. We demonstrated that in 2017, and that's one of many materials and processing techniques that we have investigated and identified as having great economic potential at the current launch operation and return pricing. Right, we're not when we're evaluating these technologies, we're not hoping for a dramatic reduction in launch costs. We're not hoping for a dramatic increase in launch cadence. We try to be very disciplined and conservative about it and look at it and say, this is what exists now, and how and what can we realistically build on that. And we're really experts in developing both capabilities for space as well as economic models for space. But we seek partnerships and relationships with folks that have the underlying technology, have the underlying capability, and leverage those relationships. So as you mentioned, Pete, as Pete mentioned, we don't comment specifically on in the specifics of go-to-market strategies until we're ready to do so. But we really do kind of evaluate each one on a case-by-case basis, and leverage partnerships and relationships as much as possible.
So we have a number of questions from Miles Walton of UBS. I'm gonna get to the first one and then do a follow-up, and then Miles will try to get to the rest of yours. Curious if you can comment on what is driving the organic revenue growth acceleration from the current quarter, which is 27%, to 85% in the out year, specifically 2025. Law of large numbers would generally lead to a deceleration, but we at Redwire see an acceleration. I'm paraphrasing a little bit on his question just to help facilitate.
Bill, you want to get in on the action here?
Yeah, I can jump in here, and I think it really is driven by a lot of the factors that we mentioned in the presentation. We're moving up the food chain. There are a lot of very, very large programs that are coming out today, and it's that 1 + 1 = 3, 4, and 5 or more scenario there now. So as a one Redwire, with this broad base of capabilities, we're able to go after these much larger and larger programs, and we're still a relatively small player in the space marketplace. So, growth for us, what might be 30, 40, 50% growth for us is single digits for some of the larger players in the marketplace. So we can gain market share, we can garner larger and larger positions on these major programs and accelerate our growth faster than the overall market is going to grow.
Great. One follow-up for Miles. Can you comment on the recurring revenue in the business model?
Let me take a shot at that one too. As mentioned, we have a number of continuous product lines, our sun sensors, our star trackers, the rollout solar arrays, many of our deployable structures that are on platforms. And as those platforms expand and continue, we do have a certain amount of kind of repetitive come back to the well type business. And obviously we foster that and want to continue with it as we go. So it's a combination for us of new programs and expanding with new technologies and continuing with this baseline good foundational product that we have.
Yep, I'll add to that we're a very IP-driven company. So because of that, most of the programs that we're involved with those programs because we have a specific IP. And that IP is what generates a lot of recurring revenue because as those programs advance, they need more and more and more of that kind of technology. We also have a number of multi-year programs as well where our technology becomes so embedded in the program that it's going to lead to really high probability follow-ons as well. Andrew, you want to add anything else to that?
Yeah, I mean, just to tag onto that, our products, if you think whether it be solar arrays or navigation components or cameras, they're often very, very sticky, right? That they're reliable, they're trusted, and so when a customer they buy one block of satellites, so they buy one block product from us, and then when they go to build the second block and the third block and the fourth block, they don't take out you know, an ADCO star tracker from it and replace it with somebody else's, they come back to us. So that represents a significant amount of recurring revenue in our model.
Good question.
Let's take another retail individual, Dennis Murray of Mula Mula. Thank you for the presentation. Do you know when the stock merging date is?
I believe that was in the S4. You want to?
What we have signaled is that we expect to close the transaction in Q3. We've not gotten more specific than that.
Great. Let's take Mike Simmermoli from Truist. How does your 2025 revenue forecast take into account failures of customers? Not all startups will succeed, in addition to program cancellations and delays.
Yeah, that's a good question. So again, going back to that portfolio effect, we don't have one particular technology that we are saying, hey, this technology is going to be so prolific that it's going to be in and of itself accounting for the entire $1.5 billion. That gives us a lot of resiliency as a company. It allows us to pivot as the market pivots. As we articulated in the briefing, whether it's a civil, national security, or commercial mission or capability, Redwire has a role to play. So that kind of agility and flexibility allows us to move the way the market moves. So if you have one high-profile failure, we're able to easily adapt. All of our multi-billion-dollar unfactored pipeline is factored to account for that in our projections. We know that we will have some bumps in the road, but we also know that we'll have some surprises that were factored perhaps lower than that, and that $1.5 billion forecast accounts for those different variables into the marketplace.
Let's take Jake Hannigan from Sony. Do you think your Reg ISS tech will help you win the NASA Break the Ice Challenge, which seems a very exciting project that Redwire could be involved with?
So I'm very happy that we got a question here for Mike Snyder, our CTO, and specifically on the Moon Regolith printer, because that is a technology that I think is really exciting. So Mike, over to you.
Definitely exciting. So the regolith printing experiment on the ISS, we're looking at that more as the foundational element of producing things on the lunar surface based upon customer demand. That includes NASA as well as commercial customers like SpaceX. So really we're looking at it as a manufacturing capability. I'm pretty sure we didn't even put that into our Break the Ice Challenge. So part of our innovative culture is we actually have employees that come up with projects and things they want to do, and we encourage that. So our entry there was employee driven, and we didn't actually put in all of our top level strategy into that just so they can innovate as they want. But definitely it's complementary to any lunar activity, including things that are excavating and throwing dust all over the place.
Excellent.
Great. We will take a question from Credit Suisse's Scott Mikas. As you grow and scale, are there specific programs, government, commercial, or civil, that you would call out as potential franchise opportunities, either with others or internationally? I'm paraphrasing to be able to help Scott out a little bit here.
Yeah, no, great question. Again, I go back to when space wins, Redwire wins. So the momentum of all the really large projects are ones that we're lining up to get of. And again, we don't comment specifically on any of our capture strategies. But if Al out there in California would like to take a shot at this, Al, any thoughts that you would like to add?
Yeah, no, it's a great question, and we referenced some of the missions that we're have a close eye on. Of course, Artemis is a big venture, and it's a global, international venture. There are a number of countries that have signed the Artemis Accords. That gives you the sense of the global nature of it. And I think that Artemis is one example of where we will shine, and already are shining. So Yeah, again, we can't comment on the specifics of opportunities, but anywhere where, example, navigation, robotics, solar arrays, I mean, you can imagine that those are relevant to a number of programs, sun sensors, star trackers, and we're very aware and engaged with, government and commercial missions across the board. So I wouldn't highlight any one as the leader, but just know that they're all on our radar, and we're engaged in a healthy pipeline across them. Thanks.
Scott has a follow-up. In commercial aerospace, suppliers benefit from high barriers to entry due to the rigorous process to certify parts with the FAA or EASA. Is there a regulatory barrier to entry aside from patents that protects your space products and can enable you to leverage revenue power? As a follow-up, is there any regulatory barrier to entry for parts or components used in space hardware? As a big picture question, how long does it typically get to get a part certified, if there is a certification process for use on space hardware? This is a heritage question in many ways too.
That was a lot to unpack.
I know.
But I understand the spirit of the question.
Yeah.
So I apologize if we don't hit all the details of the question. But yes, each program has very rigorous specifications that they require a supplier to meet in order to become a part of that program. And over time, you become built into the program. I don't want to comment that it's regulatory in nature per se, meaning there's certain laws that require it. There are a number of emerging legislative trends towards a focus on a U.S.-based commercial supplier, which Redwire is, when dealing specifically with the national security market. That is a tailwind for us. So you mentioned the IP. That is a key portion of it. But I'll say globally, anybody that has worked in the space industry for even a short period of time knows that flight heritage is the coin of the realm. And that's why we focus so much on this heritage plus innovation. It's not popular among our customers, in many cases, to be the first to demonstrate a capability on a very mission-critical deployment. So having that flight heritage, understanding the space environment. Space is truly unique. You just can't. I've been involved in the software industry early in my career. 3 people can kind of get into a garage and start writing code, and over time that can be very effective and deployed pretty rapidly. Space isn't like that. You have to know what you're doing. You have to understand the harsh environment of space. You have to understand the qualification procedures that are required for the rigorous engineering and development that goes into making these kinds of solutions. So yes, there are an extraordinary number of barriers to entries that I think are even beyond what the aerospace community has in terms of being able to effectively deploy space capability. Andrew, you want to expound on any of that?
Yeah. I think there's 3 big moats that we have here. One is, as the questioner mentioned, is the IP, right? That is a moat. The second, Pete, is what you were just talking about with is flight heritage, right? There's an incredible bias toward flying things that have flown before, that have high technology readiness level, or are tied very closely to that, which is why we have such a long, great history with some of our products, and demonstrations and operationalizing things like via programs like IROSA, via programs like Archinaut One are so important. The third is actually. Are those mission requirements? There are systems engineering bodies and manuals like SMAD that people use throughout civil, commercial, and national security that you have to be conversant in, you have to deliver for, and the customers are very, very demanding. So that is a third barrier to entry, both for the specific mission, as well as having that knowledge within us. In terms of the time it takes, we actually pride ourselves a lot in reducing the time that it takes to qualify, to qualify products, because at the end of the day, customers don't want to pay for that, that non-recurring engineering. They want to buy things on a commercial basis. So leveraging our digital engineering techniques, being able to digitally qualify things, that's where we're driving and providing some innovation. In addition to having, deep moats in those three areas that I just laid out.
Yeah, and I'll add a fourth, facilities and equipment. As Faith laid out in her slide, we have some really unique facilities. IROSA is obviously a 3-story high bay that's capable of doing very sensitive space development work. So the fourth one that I would add to Andrew's list is that unique capabilities such as clean rooms and testing thermal vac chambers and the like. So,
great. I do want to give a retail investor a follow-up. We do have Ryan Cohen, who we led off with. He asked a question concerning biological 3D in the future and what IP or technology we have, how we think about it at Redwire. And I'm going to throw that out to the team.
good question, interesting question. We have IP in that domain. We are looking at that segment very hard, and we have a number of ongoing initiatives that we're not at liberty to discuss at this point. But I think what I will say, and why I like the question, is we're very aware of the potential there, and have that in our roadmap as capability that we're very interested in continuing to explore. Andrew or Mike, do you want to? Mike, why don't you take this one?
Yeah, so I won't comment what kind of the ongoing internal stuff, but I can comment that we've actually made our facility on ISS modular enough to upgrade to bioprinting capabilities. In fact, we have tested bioprinting capabilities on parabolic aircraft and can do those materials and those substances now if the mood strikes us, so to speak.
If the mood strikes us. We need a slide. Our moods and what's striking us.
Great. So we have a question from Colin Canfield of Citigroup. Discuss how launch providers influence your cost structure, the competitive risk of larger launch suppliers moving perhaps into 3D printing and in-situ resource utilization.
Yeah, great question. Thank you for that. We love launch providers. The more mass that they can launch cheaper is just a huge tailwind for Redwire. Obviously, we're putting up a lot of space-based infrastructure, and as I pointed out, the cost of launch goes down. There's a direct correlation to the demand for more space infrastructure. In terms of the launch providers or anybody else getting into 3D printing on orbit or some of those in-situ resource utilization, this is not technology that was invented overnight. We have a long history of working with NASA. I believe we put our first in-space manufacturing capability on the ISS in 2014. So we are not in the deep research and development phase where anybody in a lab right now who can produce, produce a 3D printer that could ostensibly operate in microgravity would be able to catch up to us in a really short period of time. There has just been a tremendous amount of investment that has gone into this from our customers, from our legacy organization, Made in Space. So I don't have any, we're not really looking over our shoulder. They would have to invest in a lot of money. It would basically be the equivalent of saying, right now to date, if Redwire had in our deep technical capability here aspirations to create a reusable rocket, right? So I would say that I'm as concerned about the launch companies getting into 3D printing on orbit as I am, and they should be concerned that Redwire is going to get into reusable rockets, and that's the way I would kind of characterize it now. Andrew, you want to add anything to that?
Yeah. I mean, we're just as a participant and professional in the space sector, it's really exciting to see more launch providers come online, and as launch cadences go up, we more often than not have hardware going up, and so there's really a synergy, between us and launch providers, and that's a great synergy. We really are proud of the relationships that we have with folks at these different providers, and it also is exciting as folks that have been very thoughtful about additive 3D printing and what it can mean, how its transformational potential, to see folks at SpaceX, see folks at Relativity, and other companies apply additive manufacturing techniques to simplify their designs, to lower the cost of production, and ultimately lower the cost of delivering things on orbit. Because it's really more volume going to space, just as you said, at lower cost. Let us do more and let us deliver more for our customers, and it's just a really exciting time overall. And we'll all be working together to commercialize LEO and enable sustainable lunar exploration and operations and beyond.
And by the way, if Elon Musk is on the line, that was not a challenge, but but maybe, who knows? Reusable rockets could be. But I'm sure he won't be shaking in his boots anytime soon.
Miles Walton will give you a shout out for another question from UBS. You acquired 7 companies in just over the last year. What is the pipeline for new deals, and what is the strategy on financing these deals going forward?
So we're not going to comment, obviously, on any particular opportunity in the pipeline, other than to say that we do have a number of opportunities that we are currently looking at. We were on a great and rapid trajectory associated with mergers and acquisitions to date. We decided that it was good to take a strategic pause in order to execute this spec, specifically to put dry powder on the balance sheet so that we can continue our proven track record of M&A. So we do have a very robust pipeline. We didn't stop talking to people that we were talking to 6 months ago. We're really well connected as part of this founders network that I was talking about. I think we have a lot of great, when I walk in, the first couple of acquisitions that we did as Redwire, when I would walk in the door with our partners at AE, who have a tremendous reputation, and that was a tailwind for us. But largely, they were kind of like, who are you? Why should we talk to you? Now we don't have to overcome that hurdle. They know who Redwire is. I can bring people like Andrew and Mike, or Stan Kennedy and Maureen O'Brien, the founders of Oakman, or any of the other founders in the door with us, and they can articulate what a benefit of being a part of Redwire and the scale that we bring has been to helping them achieve the things they wanted to achieve as a small business by what we call joining the cause and becoming a part of Redwire. So we have a real tailwind, and I believe a strategic differentiator when it comes to mergers and acquisitions. And in our S4, you can see that we list our use of proceeds as continuing to do mergers and acquisitions. So we'll be financing that M&A with the cash on the balance sheet. And of course, being a public company, I think, is a tailwind for us because it provides a liquid currency for us to offer prospective sellers as well.
We actually have 2 retail investors that have virtually asked the same question. So Luke Short and Da R, you both asked questions roughly similar. Has COVID drastically changed Redwire's business? And speak a little bit to the global chip shortage, if it impacts Redwire, or any supply chain issues.
COVID has changed life as we know it on the planet, and Redwire certainly was not immune to that. However, we are extraordinarily proud of the fact that we were able to continue our operations effectively. continue to execute our strategy. It's truly a testament to the resiliency of our employees, their dedication, their commitment, their responsible response to the pandemic. So yes, we were impacted by COVID, like I believe every organization was, but we were able to work through it and continue to grow effectively during that time period. Was there a second part to that question?
The supply chain.
Oh, the supply chain. You know, again, supply chain is something we keep an eye on. We are not a mass chip buyer because we do in small volumes in space. Then you would say you're very highly visible automotive industry and what they're going through with chips, or certainly cell phones or anything like that. We tend to do lower volumes. So although we have an eye on the supply chain and we're working through, like we always are with any long lead items, I wouldn't say that it's a material headwind for us at this point in time.
Great. Just a reminder to those on the call, please ask your questions, especially people who have not asked a question yet, through the website, and we will do our best to get to those questions. So I'm going to do a repeat now from Greg Conrad at Jefferies. A lot of capital has been invested in space, which is fueling the potential growth. But how does Redwire view this as changing the competitive environment? How does new space companies or new space as a growth driver compared to new space as an emerging competitor?
Okay. We like to say when space wins, Redwire wins. We also like to say that space is a team sport. This is a nascent industry in comparison to other industries that have been around for a really long time. As capital flows into the space industry, we see that as actually growing potential market share for revenue. So we're excited about capital flows that come into the industry because in many cases that capital is flowing to Redwire as part of us providing a critical piece of space infrastructure to enable a new business model. So I talked about that. I put up the space commercialization slide, and I talked about how the reductions in launch costs are enabling business models that heretofore have been impossible. As money flows in, many of those business models are more focused on, say, selling data, for instance, than they are, or having a certain payload, proprietary payload, than they are on the infrastructure of space. So that's green fields for us. Every time I see a new space solution get funding that is going to require the deployment of space infrastructure, we get excited about that. However, we're not oblivious to the fact that as investment comes into the industry, they'll be investing in competitive capabilities, but right now the demand far outstrips the supply, so we don't see that as a threat. And in all industries that are new, we actually see that as a healthy indicator, right? If nobody, as I've always said, if nobody's competing with you, you may not be focused on the right market because somebody at least should see the opportunity as well. And try to put together a competitive organization. So I'll just wrap it up by saying capital coming into space is healthy for the industry and it's healthy for us.
Great. We will take another question from Mike Ciamoli from Truist. How fast does the commercial revenue side of your business grow? It's only 12% of revenues today, but all your startup customers have material hockey sticks growth modeled out through 2025. What is government, civil, and commercial mix 5 years from now? And are the margins better for commercial? I think what he means is compared to civil and government.
Yeah, no, that's an excellent question. Again, we had some statistics, and I'll turn over to Bill here in a second. that we shared. But again, I want to underscore our flexibility and agility. We work across civil, national security, and commercial. Advances in any one of those is a tailwind for us. Any challenges associated with any of those, we're able to pivot to another industry. We do see commercial as being the fastest growing segment in the space industry, and I think this question dovetails really nicely with the previous one about the inflow of capital. So we believe that commercial will be a faster growing part of our business based on the current economic landscape out there, and so that it'll be a growing and profitable portion of our future market share.
Yeah, I think that's right, Pete. In our projections, we have all of our segments growing, whether it's civil, defense, or commercial. We're projecting in 25 to be roughly about 20% civil, 40% defense, and 40% commercial. As far as profitability, I don't think profitability really is skewed that much based upon the nature of the customer. It's more based upon the nature of the program and how we're contracting that program. If it's more of a development program where there's risk and it's more of kind of that cost plus fixed fee type scenario, then those are going to be lower margin but less risk. On the flip side, if you have repetitive manufacturing, you're doing the same thing again and again, we have a low degree of risk, we have a high degree of confidence in the product. We're going to contract that as a firm fixed price product. We're going to have a lot of intellectual property in that. We're going to get strong margins out of it going forward.
Great. Next question comes from Nacho Cordoba of Cordoba Capital. Good morning. The Redwire companies are fully owned by Redwire, or is the ownership only a percentage of the company? Is Made in Space fully owned by Redwire, as an example? So it's a question about ownership of the entities.
Sure. Yes, all acquisitions that we have made to date are 100% owned by Redwire. Some of the founders have obviously participating in the go forward Redwire, but that's in Redwire equity. There is no such thing in our lexicon as the Redwire companies. You saw a logo on one of our slides about One Redwire. We have a tremendous amount of experience as a management team on integrating companies. Again, that's why I foot stomped during the introductions, the tremendous amount of M&A experience on the team and how we view that as a competitive advantage. So we're actively and actually ahead of schedule in terms of our integration strategy. These companies have come together as a single Redwire, and that's how we go to market. We do sometimes use the brands that we all own on a product level basis because of the heritage associated. So nobody ever gets fired for buying AdCol sun sensors because of the space heritage there. So we will refer to them as the AdCol sun sensors or the AdCol star trackers. But the entity itself is a fully integrated One Redwire, and that's how we go to market. So, and of course, we own of all of them.
Great. We'll take a follow-up question from Scott Mikas of Credit Suisse. When evaluating M&A opportunities, what are the criteria that you use? Are you seeking high growth, pre-revenue type companies, or more mature companies that are already cash flow positive?
Yeah, great question. We love to focus on cash flow positive companies. There's two companies that we look for. We look for small businesses that are dominating a specific technology niche, but have a tremendous amount of flight heritage, and they just haven't scaled, whether it was a lack of capital or a lack of sophistication or a lack of desire, whatever. But now many of them typically will have the tiger by the tail with a new procurement. They're seeing a large influx of demand, and they see the benefit of being part of a larger platform in order to execute their larger vision for the capability that they basically spent their time building as part of their companies. That's one type. Those companies are obviously revenue generating companies. Our expectation is that they all be cash flow and EBITDA positive. But we do invest in disruptive companies. We look for those companies that have crossed the valley of death, so to speak, and have demonstrated that they are very close to or at cash flow positive positions, and that they have gained market acceptance and could be, if they're not already, within cash flow positive within a 12-month time horizon, and that's typically where we spend most of our time looking at from acquisition perspective. That's not to say that if we encountered a truly disruptive capability from a small business that was not cash flow positive, particularly if it aligned to one of our strategic focus areas, that we wouldn't take a look at it. But our performance to date has been focusing on cash flow positive businesses, and our intent is to continue to do so in the future.
Great. Let's pick up another retail investor who has an outstanding question. R is asking, what are you doing to reduce waste and operate mission-free? This is in essence an ESG question, of which, by the way, I'll give you credit, you're the only one who asked an ESG question. So, but anyway, that's for you, Pete, and the rest of the team to answer.
Yeah, and we're talking about like space debris and just operating in general.
So you say reduce waste and operation mission-free, and I'm assuming that's in the universe.
Okay, yeah, universally, yeah, because we think galactically, universally. So so that's an excellent question. So as you can see that we put sustainability into our mission statement: reliably, economically, and sustainable space infrastructure. We as a management team are very passionate about the environmental impacts associated with things like space debris, but also our production facilities as well. And our employees expect that from us because they're very passionate about it as well. Actually, many of our capabilities that we develop, such as the robot arm and a number of other deorbiting capabilities that we have as part of our product line, are actually focused on the cleanup of space debris. So that is important to us, and in addition to being a good thing for the solar system and specifically here on Earth, from an environmental perspective, it's also a growth area from a financial perspective, in terms of it's a big problem that needs innovative solutions to solve. So we're looking at it from that perspective as well, which is nice when that aligns up with doing the right thing. So, Andrew, anything you want to add to that?
Yeah, I think you're absolutely right to highlight the products and services that you were talking about. We've also developed and turned over like deorbiting devices for satellites in lower Earth orbits. Additionally, like in a more Earth-based way, we are active in our communities from an environmental sustainability perspective. Just more recently, as an example, we've done a river cleanup here in Jacksonville, Florida. We've done some similar activities in the Colorado area as well.
Great. Not to be self-serving, but we have a retail investor, Lon Jones, and actually some institutional investors have asked the same question, so I'm going to combine it. Can you speak to how Genesis Park chose Redwire as our partner? I will answer that question if that's okay with you.
Over to you, Jonathan.
Thank you very much. So, look, we're very humble as Genesis Park to partner with Redwire. I will say this. One, we were one of the first SPACs to go public as an aerospace SPAC. We did it when it wasn't that cool, and we had a number of other competitors also go public because we think the space is, whether it be aerospace or space. That being said,
Maryland, if you don't mind giving some of your thoughts, I know you're leading our efforts right now in implementing an ESG policy for the company. Faith, over to you.
Yes, exactly. I did just want to add in that it was a good question, and as Pete and Andrew demonstrated so clearly, Redwire is very passionate and committed to environmental issues. The program is currently being developed, and one of our first steps is really identifying what our current footprint is and then identifying the metrics we need to track to show progress in reducing our footprint. But some of the early steps that we have taken is we've combined some offices that are geographically close to each other, which has reduced our energy use and thus, reduced our emissions as well. And then we also just recently initiated a remote work program, which reduces commuters on the road and thus reduces emissions as well. And at present, we have about 60 employees that have submitted requests to participate in this program. So that is also going to have an impact on reducing emissions. So some early steps, but just demonstrating our commitment to our environmental support.
Excellent. Thanks, Faith.
Looking at the question queue list, we have roughly 3 more questions left, and because a number of the questions have already been answered that were in the queue from other previous retail or institutional. We have a question from Jeffries. How do you view your competitive positioning in the satellite value chain? How do your modular products enable a more efficient constellation?
Yeah, so we're all in on digital engineering. I love this question because it gives us an opportunity to compare our approach. We believe that digital engineering, which has proven to be highly effective in other industrial approaches in terms of cost savings and better performance, is a big part. And we've invested heavily in our digital engineering software solutions, which has the capability to model everything from single components through a full satellite up to entire constellations. That kind of pre-work before you actually start bending metal is really important to cost reduction. And Andrew actually had a slide on that in the brief, so I'm gonna turn it over to him to talk a little bit about some of that focus.
Yeah, I mean the approach with digital engineering of doing the design and validation in a modeling simulation environment really lets us tailor our solutions in a cost-effective way, in a quick way for a customer, for a constellation provider, and that's really attractive to many constellation developers. But also more broadly, when we think about constellations and we think about our product lines, every satellite needs power, every satellite needs navigation, every satellite needs needs some sort of comm or antenna. Those are all things that we at Redwire provide. And the way that we've approached those product lines is to develop those product lines that are modular and extensible and adaptable with in a very low cost way. Extending that out a little bit further, thinking about these larger constellations, it's really great to have a partner in Aero Equity Industrial Partners that has a lot of high rate, low cost production chops. And to be able to leverage that expertise when we start contemplating, producing not 10 solar arrays, not 10 chipsets of solar arrays, but thousands of chipsets of solar arrays.
Absolutely.
Next question from Micah Stewart. I'd like to know how or if Redwire is planning or thinking about future mega infrastructure projects like the space elevator or a Dyson sphere.
I love those kind of questions, by the way. And I know Mike Snyder is going to leap across the table to jump into this, so I'll be brief in just saying, although I will not comment specifically on any one of our things in the science lab, the mad science lab that we're working on in terms of future capability. I think what that question makes me think about is just how important it is in space. Manufacturing is to building large structures in space. It doesn't matter what it is, whether it's a space elevator, a lunar base, a cislunar capability, or even in our own Earth orbit. Really large structures in space require Redwire's IP and technology, and therefore we're excited about any feasible project that could leverage that capability. It's a tailwind for us. Mike, do you want to comment on any of that specifically?
Sure. So it's actually part of our philosophy is kind of think long term and then work backwards and then see what we can do near term. So the Dyson sphere, it's a great example of how to utilize in situ resources and in space manufacturing assembly in that long term. And some of our current project flows are influenced by that capability. The space elevators are cool too. The efficacy of one on Earth yet hasn't been proven, but they're kind of cool if you look at the Martian and the Pluto system, how they could work there. And obviously we'd support that long term if anybody wants us to build it for them.
Another example of how if space capital works its way in for a space elevator manufacturing company, we would absolutely be there and ready to benefit from that influx of revenue.
Not to get too practical here, with a follow-up question from one of our retail investors, Menno. Why did Redwire choose, or the rationale for going public with such a relatively lower valuation compared to other companies at a higher valuation? So that's the general question.
Yeah, that's a great question. We have a lot of information about this actually in our PIPE presentation. But we believe that our valuation is very fair. We wanted to come out at a valuation that would position us for the long term. Like I said, we're long-term focused. We want our shareholders to be rewarded for sticking with us as we move through our strategic plan. So when we took a look at the market, we tried to target a valuation that we felt would meet our capital needs in the near term, while still being fair and providing some upside for the shareholders long term, and without us having to kind of look over our shoulders. So I think I don't worry about the relative so much as I worry about the needs we have from a capital perspective, and just putting a fair market value out there from which to attract capital to go and execute our plan. And that's really how we thought about it.
As Genesis Park, given that we're part of that, we think exactly what Pete does, but we also think tremendous upside here, as you see the company performing this quarter, and as the year's going to come by. So we believe in exactly what Pete said, but we also believe absolute tremendous upside as we go forward. All right, last two questions. Scott Mikas has a follow-on from Credit Suisse. Looking at your current backlog, can you provide the mix of cost plus and fixed price contracts? How do you expect that mix to change as you go forward?
Bill, that question has your name all over it.
Yeah, and we don't typically kind of break down our numbers that way in a great deal of detail. We do have a mix of both of all three: firm, fixed price, time and material, and cost plus. As I mentioned earlier, it's really driven by where we are in the product phase there, and where our customer is in the definition of their scope of work. To the extent that we're comfortable with the risk associated and with the technology associated, we like to go firm fixed price whenever we can. We believe that there are opportunities to grow our margins there. But at the same time, we are well situated to operate in all three environments. We have all the systems and processes in place to operate in all three of those environments. And we think it's healthy to have a mix across those as we grow the business. I think as we move towards more commercial, and as we grow our various product lines, I think we will have more opportunities to be even higher capabilities of firm fixed price and kind of repetitive, customizable COTS type offerings in future years.
Great. So we began with a retail investor, and we're going to finish up with a retail investor who gets the Dion Waiters heat check, the most for the least. Da'ar has two questions. He does preface it with a stupid question, but there are no stupid questions. Da'ar, first one is, and I'll combine the two questions he has. Could you 3D print Bitcoin miners in space, run them, since there is an unlimited amount of landscape, energy, sun, cold up there to be able to do that, and can AI be involved? You asked for it, you got it.
This is a great opportunity to highlight that if you go to www.redwire-space.com and want to submit your resume, we are always open to attracting out-of-the-box and innovative thinkers. So, yeah, that's an interesting question. I'll let Mike comment on the feasibility of the specifics, but I will tell you this. I actually love this question because power is really an extraordinary capability in space that we are just starting to really understand the feasibility of what we can do as we create these larger but in great form factor deployable solar arrays such as the iROSA. And so we have a lot of people coming to us and saying, well, okay, what new things could we not do previously that we can unlock now because of this rollout solar array capability? And that's really exciting. It's also, we're very focused on compute power at the edge. We haven't talked a lot about it, but we have a number of initiatives underway internally that are looking at compute power on the edge. So when you combine and you think about the evolution of terrestrial infrastructure, which is how we think about the go forward with space infrastructure, going back to my space commercialization slide, where we talked about the analogies there, we think the combination of highly efficient deployable power structures, some of them built using 3D manufacturing, being really large structures in space, combined, that feeds additional compute power that can do really extraordinary things like Bitcoin mining in space. I guess we don't even have to go to an asteroid mine to mine platinum. We can just go to the moon and set up Bitcoin servers. But that's my thoughts on it. Our Bitcoin. I will now turn it over to our cryptocurrency expert, Michael Snyder.
So I didn't actually breach the topic of space-based power, but this is a good opportunity to. So obviously you have that tremendous resource available from the sun offputs, and I should have mentioned this with the Dyson sphere question. But our systems, we can leverage those capabilities in the future to build those types of power generation capabilities that then beam power back to Earth. Paradise regained, we can, get off, fossil fuels and all as well. But in terms of this, that von Neumann machine I was talking about before, that would be an example of this, where you just send commands where it self-replicates and makes the same thing over and over and over again, and you can do, you can mine literally, in a literal sense physically or in a digital sense. It wouldn't really matter because the computer does not, the digital assets doesn't understand, one from the other. It would just be programmed to do what it's told. So yeah, it's a great example of using in situ resources and space-based power to leverage that, current demand for Bitcoin.
And I just want to highlight that here at Redwire, we are cryptocurrency agnostic. So Bitcoin, Dogecoin, doesn't matter. If there's a solution out there and somebody needs space infrastructure in order to set that up, we'd be happy to work with them.
We have actually gone about 10 minutes longer for the Q&A than we originally advertised, so we have no other questions, Pete, so I'll hand it over to you.
Yeah, I just want to appreciate or thank everybody for attending today. Hopefully it was informative. We're very excited about the trajectory that we're on, and I thought that the questions were particularly insightful. So thank you for participating in that way. That's a wrap.